When you're drawing Lewis structures, you have to be able to tell whether a molecule is polar or nonpolar. And it's pretty simple, actually. Um, how do you tell if a molecule is polar? If you look right here, the way you tell if a molecule is polar is simply if one of these things is true about the molecule, it means it's going to be polar. If none of them are true, it means the molecule is going to be nonpolar. So what are the things that you have to look for? First thing you have to look for is you have to look for if there are lone pairs of electrons on the central atom. So if a molecule has lone pairs of electrons on the central atom, it automatically makes it polar. Um, Second thing you have to look for is terminal atoms. If the terminal atoms are different elements, we talked about that in class on Friday. Terminal elements are the elements that are directly connected to an atom or central atom. If they're different elements, automatically the molecule is going to be polar, and I'll show you what that means. The last situation is if you have a molecule that is only made of two atoms. So it's just two atoms, and they're different. There'll be a difference in electronegativity automatically, which will make one end slightly positive, one end slightly negative. If you get through all three of these, if you look at a molecule and none of these apply, that means the molecule will be nonpolar. So that's the key. You're basically asking these three questions. Are there lone pairs of electrons on the central atom? Are the terminal atoms different? Or if there are two elements only in the molecule, are they different elements, which means there's a difference in electronegativity. Now we'll look at some of these and apply, and you'll be able to tell. So if you start, here's the Lewis molecule right here. First thing we look at is the central atom, C. Lone pairs of electrons? There are no lone pairs of electrons. Second question is, are the terminal atoms different? And in this case, they are. You have two H's and you have an O. This molecule automatically is polar. We go to the next one here. That's the Lewis structure for carbon dioxide. So when I go to look at the Lewis structure for carbon dioxide, what do I notice? Well, carbon dioxide has no lone pairs of electrons on the central atom. The terminal atoms are oxygen and oxygen, so they're no different. And it's not made of two elements, two atoms. It's got more than two atoms. So therefore, this means that it is automatically going to be nonpolar, because it basically said no to all three of the questions. Next one. This Lewis structure down here. Look at the central atom. Lone pairs of electrons on the central atom? No. Different terminal atoms. I got an H, I got an N. That molecule is automatically polar. Next set. Look at this molecule right here. First question. Lone pairs of electrons on the central atom? No. Different terminal atoms? No. And it's not made of two elements, only two atoms, so this would be a non-polar. We would say this molecule is non-polar. When you look at the next one, when we refer to being polar, we're talking about that one side would have a positive charge, one side would have a negative charge. It has poles. So if you look at this one, first question, lone pairs of electrons? Yes. Right there, I see them. That automatically means that this molecule is polar. Next one, SeCl2. I look right here. First thing I see on the central atom is lone pairs of electrons. This molecule will be polar. This one. Go right to rule 3. Or the third thing I asked, since it's only made of two elements. Are the elements different? If they're different elements, automatically one's going to be more electronegative than the other, causing the molecule to be polar. So in this case, this molecule is polar because it's made out of just two atoms. 1, 2, and they're different. Next one. POCl3. There you go right there. There's a Lewis structure. No lone pairs on the central atom, but different terminal atoms. You got 3 chlorines and 1 oxygen. Automatically makes this molecule polar. I look here. Zoom in here. SO4 2-, no lone pairs. Same terminal atoms, and it's not made of two, so it means it is a nonpolar molecule. Just happens to be an ion. Next one. Xenon with 4 oxygens. This automatically is going to be nonpolar. No lone pairs of electrons, no different terminal atoms. Let's look at some other ones here. This one, NF3. First thing I notice is the lone pair of electrons on the central atom. That molecule is going to be polar. Next one is SO3, 2 minus. First thing I see, lone pairs of electrons, automatically makes that molecule polar. PO3, 3 negative, lone pair of electrons, polar, lone pair of electrons, polar. If you look right here, this molecule is nonpolar. No lone pairs of electrons on the central atom, and all the terminal atoms are the same. This molecule, because of the lone pair of electrons, is automatically going to be considered polar. This one is tricky. Notice how it has lone pairs, but it has 2 lone pairs that actually offset each other because it's an expanded octet. We actually say that the dipoles, the polar trend in this, actually cancel. So this molecule is kind of tricky because it's actually nonpolar. And that only happens in certain instances. Very rare, but it does happen. This molecule, would you say is polar or nonpolar? Well, no lone pairs of electrons, but I have a different terminal atom, which automatically makes that molecule polar. Next one. Look at this little structure, different terminal atom, automatically is going to make this molecule polar. Next one. Carbon dioxide, I think we did this one before earlier, so I'll skip it. This one, if you look, no lone pairs of electrons, same terminal atoms, we're going to say this molecule is nonpolar. Last but not least, ClF3, I have 2 lone pairs of electrons on this one. It's not an expanded octet. No, it is an expanded octet, but they don't cancel because there's only 3. Because there's only 3, this side would have a slight negative when we lay this out. So that means this molecule would definitely be polar. So the key when you're doing the homework this weekend, first and foremost, is you want to look at making sure that if you have lone pairs of electrons only on the central atom, automatically makes it polar. Different terminal atoms automatically makes it polar. If it's only 2 atoms in the whole molecule and they're different, means different electronegativities, polar. If you have no to all of these things, you have a nonpolar molecule. Pretty much 90% of the time you're just looking at 1 and 2. Alright, and that's what you have to do on your homework. Classify the geometry and classify whether they're polar or nonpolar. Have a good weekend.